The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so I'm going to work through problem number 14 for Physics 2020, the midterm exam 2, year 2006. And this problem says, an object weighs 10 newtons in air, and it is 1 newton when submerged in mercury, whose density is 1.36 times 10 to the 4th kilograms per meters cubed. And it's asking us to find the density of the object given this information. Alright, so let's basically say that we have a ball. Let's say we have some sort of object, or it could be a ball in this case, and let's just say that we have, so this is a ball, and this is basically our liquid is equal to mercury, alright, and so this ball is submerged in this mercury liquid, and in the air, the weight of the ball is equal to 10 newtons, all right? But in the, so this is in the air, and in the mercury, the weight of the ball is equal to 1 newton. So basically we can see that in order to solve this problem, we're going to be relating or using the concept or theories of Archimedes' principle. Okay, so if you go and to the supplemental formula sheet that's given for this particular exam, you'll see the relationship for Archimedes' principle. And basically it states that so we have, so this says that the buoyant force is equal to basically the weight of the object that the liquid is holding up, okay? And so basically if we have the weight of the object in a liquid, if we set our coordinate system where we have, this is the positive x direction, this is the positive y direction. If we have an object and it's basically submerged in a liquid, the weight of that object is going to be having a negative force vector going down, and the buoyant force, which is the force that the liquid exerts onto the object, is going to be pointed up. So it's actually counteracting the object, the weight of the object, in order to basically make it float. Now, if these two forces are equal, then your object is going to float. If these two forces basically are not equal, then your object is going to sink. Okay? So in this particular problem, it says that the object weighs 10 newtons in air and it weighs 1 newton in the liquid. So basically if it was going to float, these two forces would be equal. Your buoyant force would equal to your weight force. So the object actually is going to be sinking in this particular case, because it's actually going to see a weight of 1 newtons. It's not going to see a weight of 0 newtons. If they were equal, the liquid would actually see a weight of 0 newtons, because these two forces would balance out. So basically what I'm trying to say is that in air, the force weight is equal to 10 newtons. So this is in air. So the force of the weight force in the liquid is going to be 1 newtons. So this is in mercury. So what does that mean? That means that the liquid is actually having a buoyant force, the force applied onto the object, is going to be 9 newtons. Why is it going to be 9 newtons? Because the liquid is actually seeing 1 newton still. So that means that 9 of the newtons is not being seen, which is, so we have basically, so 10 newtons is going to be equal to the buoyant force plus the weight in the liquid. Okay? And so we are going to try to find the buoyant force. Well, we know the weight of the weight in the liquid is 1 newtons. Okay? So we can solve this equation. The buoyant force is equal to 10 newtons minus 1 newtons, which is equal to 9 newtons. All right? This is the amount of force that the liquid is applying onto our object that's submerged in mercury. Okay, and we got that because we know the weight of the object is 10 newtons in air, and the liquid is still actually seeing 1 newton, so that's a difference of 9 newtons that the liquid is applying onto this on the object, which is the buoyant force. Okay, so now that we know the buoyant force, we can relate that the buoyant force, using Archimedes' principle, is equal to the density of the liquid times the volume of the liquid times gravity. Okay? And in this particular problem, we're asked to find the density of the object. So we want to find the density of the object. Well, we know the density is equal to the mass of the object divided by the volume of the object. Okay, so this is what we're trying to find. Okay, so let me make some more room here. All right. So let's try to find the mass of the object. Well, we know that the object weighs 10 newtons. Okay? And we know that the weight, okay, so the weight is just a force, which is equal to the mass times gravity. Okay? And so if we want to find, so this is 10 newtons, okay? So if we want to find the mass, all we have to do is divide both sides by gravity. So mass is going to equal to the weight divided by gravity. Okay? So we divide both sides by gravity, and we get the mass. So we know that the weight is 10 newtons, and we know gravity is 9.8 meters per second squared. So the mass of the object is equal to 1.02 kilograms. Okay, so that's the mass of the object. So we've got one part of our fraction that we need in order to find the density. Okay, now we just need to find the volume of the object. Okay, so how can we do that? Okay, so if we know that the buoyant force is going to equal to the weight force in the liquid. Now this is not the weight force in the air, this is equal to the weight force in the liquid. And we know that the weight force in the liquid is equal to the buoyant force. We know the buoyant force is equal to 9 newtons. Okay? So we know that the buoyant force is equal to the density of the liquid times the volume of the liquid times gravity, which is equal to the density of the liquid, the volume of the liquid that is being displaced equals the volume of the object, right? It's sort of like when you stick an object into like a graduated cylinder or something like that. In order to determine the volume, you would stick it in, you would submerge it in a liquid and see the displacement of the meniscus to give you the volume of the object. So it's the same concept here. The volume of the liquid displaced is equal to the volume of the object. So this is actually equal to the volume of the object. So if these two are equal, I can now substitute this volume of the object in for the volume of the liquid, in this case is mercury. So that's equal to the volume of mercury times now the volume of the object times gravity. Okay? And we know that this is equal to 9 newtons. Okay, so this is an important equation here because we're trying to find the volume of the object, and in this equation we're relating the buoyant force to the volume of the object. So we can actually solve this equation for the volume of the object because we know the density of the liquid, we know gravity, and we know the buoyant force now, which is 9 newtons. Okay? And so we can solve this equation for the volume of the object. So the volume of the object is going to equal to the buoyant force divided by the density of the liquid multiplied by gravity. Okay? And so we know that the buoyant force is 9 newtons. We calculated that at the beginning. And we know the density of the liquid, which is given in the problem, is 1.36 times 10 to the 4th kilograms per meters cubed. And we know that the gravity is 9.8 meters per second squared. Alright? And this is a volume, so we want to have units of volume. And if we do our unit analysis, we know that newtons is actually really kilograms meters per second squared, right? And so we have a meters here, that's going to be canceling out of meters there. We have a kilograms, that's going to be canceling out of kilograms. This second squared will cancel out that second squared. And so we have a meters cubed on the denominator of this fraction, but when you bring it up to the numerator, it's going to be in the numerator, so we do have units of volume here. So our unit analysis works out, and when we work this out, we get an answer of 6.75 times 10 to the minus 5 meters cubed. Okay? So this is actually our volume. Let's get the volume. The volume of the object is equal to 6.75 times 10 to the minus 5 meters cubed. Alright? So, we're asked to find the density. We again know that the density is equal to mass divided by the volume. So the density of the object now is just equal to the mass, which is 1.02 kilograms, divided by the volume, which is 6.75 times 10 to the minus 5 meters cubed. And you'll see that our unit analysis, we get kilograms per meters cubed, or a mass per volume, which is a density. So the density of the object is equal to 1.51 times 10 to the 4th kilograms per meters cubed. And this is actually the solution to the problem. So I guess the trick to this problem was we had this relationship with Archimedes' principle that says that the buoyant force is equal to basically the weight of the object in the liquid. But Since the object weighs 1 Newton in the liquid, that means the buoyant force is actually equal to the amount of force that's applied onto the object that's in the liquid. In this case, that was the difference between 10 and 1 newtons. 10 newtons in the air and 1 newtons in the liquid. So the buoyant force is actually what's applied, so that was 9 newtons. So we basically said that the buoyant force was equal to the weight in the air minus the weight in the liquid, which was 9 newtons. So that's the actual trick to this problem. Once we did that, we could simply use this relationship, and we could solve for the mass because we were given the weight of the object in air, and we could solve for the volume because we know that the amount of volume that's displaced in the liquid is actually equal to the volume of the object, and then we could just divide the two in order to get the density. Okay?
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.